Hello, what's up guys? Welcome back to next episode of my tutorials about Ardupilot and PX4 simulation. In the last video, I talked about almost everything about software in the loop or SIL or SITL or any other thing that you have heard of. This video is not a tutorial anymore. It's just an extension to add explain capability to our software in the loop simulations. So if you haven't watched the last video or just suddenly found your way through this video and don't know anything about software in the loop, go back to the last video. I will put the link in the description. So it's called Everything About Ardupilot and PX4 Software in the Loop Simulation in 1 hour. And if you are only going to use Ardupilot, you don't need to watch all the 1 hour video. I've just set some link to help you navigate through the video and find exactly what spot you need to find for configuring your Ardupilot simulation. And just to have a quick review, I told you you can use these simulation tools in Windows, Mac, Linux, or any other operating system, but I totally recommend you to go through Linux. You can use a Linux emulator in Windows 10. That's okay. That's totally okay. And just very simple steps. You need to configure the Linux emulator, and then this in the background of Windows 10 you have Linux. But I myself prefer to use with Linux. You can install it as a virtual system with VMware, virtual workstation, or you can just install a fresh copy of Linux in your dual boot operating system. Okay, in this video we are going to connect our software in the loop programming interface which is using Ardupilot to a new simulator. In the last video we used Gazebo, which is a robotic simulator, and we used Rust, which is robotic operating system, and then we used JMapSim, pretty similar with similar the Gazebo but very simple and lightweight. Then we use Flight Gear, and we talk about these stuffs. But there's another simulator very well known for all of you, which is Explain. Explain is very powerful. It's not only a game or not only a simulator. It's a very great engineering tools, both for pilots and aerospace engineers, and also the gamers. You can model an aircraft inside it from scratch based on geometry and aerodynamic properties, and then let that things fly and see how it works. Explain, you can connect your PX4, which is using Ardupilot, not PX4, Ardupilot as a software in the loop, and control the aircraft. Very simple steps, nothing very special. Maybe this video won't take even 10 minutes or less. So without talking anymore, let's get to work. And again, if you haven't watched the last video, go watch that and come back again. And you need to have the Ardupilot folder directory in your Linux Ubuntu system and Explain installed. I'm going to talk about it. Okay, let's start the work. I'm going to use this web page as a guide, just using as background, and I'm going to tell you what to do. Okay, this is a video I was talking about. Watch this video, at least the part about Ardupilot, before coming to this video. If you have done all the steps in that video, you will find Ardupilot folder in your home directory, which contains all the framework for Ardupilot, and you should install Explain 11. You see the folder here, and installing Explain is relatively easy. You can install the demo version for free from here. Simple step, just click the installer and let it download. In the free version, you only have you can control the joystick for 15 minutes. That's okay. You can close the application and open it again, and you have 15 minutes. And if you like it, it's not very expensive, you can buy it. Okay, when you download the installer, you will get this file. You open the installer, and you don't need to download any scenery. At least in free version it's not supported, and even in the paid version you don't need that unless your system is well and equipped. This is executable for Explain. I have added this icon for myself. Yours might be different. Very simple screen. For the first time, you may find the tutorial screen. Skip that and come to this page, which is the settings screen. Flight model per frame is for the calculation. If your computer is CPU is very powerful, you can increase it and have a better calculation, especially if your model is very small. And you have experimental flight model, which is more realistic but may conflict with some models. So if your model has conflict and doesn't run quiet, disable this option. The graphic option depends on your computer. If your computer is not very powerful, reduce this to just have the frame rates up. And also change the monitor usage to Windows Simulator so you can switch between Windows very easily. The main setting that you should do is on network settings. In this part, you can select what data should be communicated between X-plane in UDP protocol. You don't need to check them because the first time you run the software in the loop, these settings happens automatically, so you don't need. But just for a review, you see the data is being used is time, speeds, Mach number, vertical speed, angular velocity, joysticks, pitch, roll, latitude, longitude, and engine settings, propeller settings, generators for the electricity, mixture settings, and so on. These are the data that are being used by X-plane and software in the loop simulation. They will be checked automatically, but double check them. Here you should have a UDP rate enough for your simulation. 50 is good value, not very high, not very low. But if your computer is powerful, you can increase it. Then you have to enable the network data output. So you should enable. If you are going to use all this, run all the simulation on the same computer, you should enter localhost IP address, which is 127.0.0.1. And this one is the port that X-plane is sending data. If you are not familiar with UDP and network terminology and concepts, just don't change anything. Change it only if you know what you're doing. I have already talked about the UDP and ports communication in one of my last videos here. This one explains Simulink real time. I just introduced the UDP definitions very briefly. But unless you don't want to change anything or don't want to do anything special, don't change this. Come here to the UDP ports. The first one doesn't matter. Just put it a number, a random number that doesn't conflict with others. The port will receive on this one 49001, I guess. 000. This is a port that explains receiving data from the PXHawk, which is 49000. If you change it, you have to change the value inside the explain as well. And the next one is 49002. Do these settings and don't change them unless you know exactly what you are doing. And the next step is calibrating your joystick. If you are using a joystick, come here and calibrate it to make sure everything is working. And if you're not familiar with the explain command, check shortcuts here in the keyboard settings to know the shortcuts. Now we are running a new flight. We are running Cessna Skyhawk in Mehrabad International Airport. Sounds crazy, but okay. Here you see that a PXHawk is going to PXHawk simulation is going to stabilize the Cessna 172. Of course, it won't be that much good because we hadn't done any tuning. If we tune the OIII controller well, there will be no problem and it will be working. And since I haven't installed any scenery, I have just selected the continue with water. And as you see, because I am recording video, everything is very slow and sluggish here. So you have no idea, you have to wait and see until it loads. Right now you see the explain is all on my control. I can control anything with my joysticks because there is no PXHawk working here. Now let's go back to terminal and do what we have learned in the last video. Sorry for the performance you see because my graphic card is not so heavy in my laptop and I'm recording the video is not very good. Okay, we cd to the Ardupilot directory. Then because we are using a plane, we are going to cd to Arduplane. And every plane that we are going to use saves some configuration files. Because we don't want to just mix everything together, I'm going to create a directory with make directory Cessna test1, then cd to Cessna test1, And now we are ready to do the simulation. Just a command that we already are familiar with. There's also available in this page as well. You see different type of running software in the loop with explain. I'm going to teach you the hardest and the most completed version. The first method and second method are simple, but the third one is challenging. This is the commands if you want to run in Windows emulator, just the same, nothing is different. This one. Yeah, they have already created a directory called pt60 and then run this command. simvehicle.py and the configuration with explain simulator. We are not going to need the map. You can have it, but I don't want it because we are going to use QGroundControl. If it's your first time compiling it, it will take much long time, but it's not my first time, so it happens fast. You see it's connected and it's calibrating the IMUs, at least fake IMUs, because there is no IMU here. It's everything is in simulation. Everything is ready, but with a very low frame rate. So right now the command is not by myself. You see when I increase the power, it immediately come back because right now PXAC is controlling the explain. So right now the system is not armed, so yeah, it doesn't let me increase the power. Okay, now we can use math proxy to send command, or we use QGroundControl to connect to our PXAC simulation. Just like our last videos, I'm going to run QGroundControl or any other simulator that you like, APM Planner, Mission Planner, Droid, I guess. Right now my system is not very fast, so it takes a little while to QGround to load up. Okay, here's QGround, and it automatically connects to our simulator because we have already set the UDP connection automatically. But you see we can't use it because there are some red items here such as sensor calibration, radio calibration, accelerometer calibration. Seems crazy because there is no accelerometer here to calibrate. It says rotate the vehicle. It sounds crazy, but right now we have to full the Ardupilot pre-flight checks. We should change the parameters for calibration to make it think that it is calibrated, or do a very simple process. Come to math proxy, parameters, load. We will give it a default parameter so there won't be any pre-flight check error. Come to Ardupilot homepage. Come to tools, auto tests, default parameters, and we look for the best one is plain that param. There are different kinds of default parameter here. So I'm going to use the default plain, and voila, everything is okay and green right now because PXAC now thinks that the sensors are calibrated. But you can go to the parameters and change the function of each parameter based on what you need. For example, the servo 1 function is aileron right now. You can change it to any other things that you like based on your purpose. Okay, this is QGround and we are connected to explain, and we are now on the threshold of runway 29 left of Mehrabad International Airport. Let's check the airspeed and climb rate data so we can see the data. You can change any value here, such as bank angle, roll angles. Definitely we won't have a good flight here because we are using up parameters for a UAV, a small plane, not a Cessna Skyhawk. But just shows you the concept. Okay, let's create a mission and see how it works. I'm going to do a auto takeoff, at least a semi-auto takeoff. The pitch attitude 15 degrees is so much for a manned aircraft. I put it on 5 degrees. Take off along the runway, then the waypoints. It is kind of sharp turn. Definitely it will stall with the settings and very slow computer that we have. But just showing the concept. The cruise speed, for example, 50 meters per second for this aircraft. Altitude is okay. Just for the sake of tutorial, we can change the speeds and altitude for different waypoints. But I'm not sure if we get to the point to check all of this, because I'm sure at that tight left turn we will stall. Okay, we upload to the system, and right now if I start the mission, the PXAC is going to increase power, but because it's not a very small aircraft and it takes time to take off, I have to manually keep it on the center line. So I'm going to manually use the rudders to keep the airplane on the center line. Okay, aircraft is armed and mission is started. Hit B on your keyboard to release the parking brake, and we are going. Very slow and low frame rate. You see, I'm only manipulating the nose wheel, which means rudder here, to only keep it on the center line. I'm not doing anything else. The airplane is taking off by itself. Altitude is increasing, but very slow. It's not a safe flight for a manned aircraft. We should have at least 55 knots to climb, but doesn't matter. Positive rate 100. And just to let you know, Mehrabad International Airport is not sea level, because we are using water as the scenery. We are in sea level, but Mehrabad is about 3,500 feet above sea level. 200. Okay, we are about 50 meters. The waypoint altitude was 50 meters. Everything is good, but we are very slow. It's dangerously slow. You should change the parameter to get the best value for this item. It already started the left turn to the next waypoint. You see it? No, it's not the left. It's kind of diverging. You see, it's trying to remain on the path, but it can't. For those of you that you are engineer, you know exactly what is happening here. The aircraft is trying to track a line, but it can't because the PID value is not tuned. I think the P value is much too low for this aircraft. You see it's diverging, and finally definitely it will stall. Overbank and stall. Yes, you see the amplitude of the diverging is increasing, and soon enough we will crash. Doesn't matter. It's just I'm just showing you the concept. Okay, I think that's enough with the game, and in a few seconds we are going to crash. Great, and this is a crash. Okay, this is the hardest method for software in the loop simulation with Explain. As I told you, there are very simplest form. If you are not going to change anything, you have a very normal purpose work and haven't changed anything, you can use the way it's built in Mission Planner. Go to Mission Planner, and in the simulation tab you select Explain and just click on the plane, so on. Everything is done. You only need to install Explain and do the configuration I told you here. When you click on the plane, suddenly everything is done and Explain is connected to your Mission Planner. This is the simplest form, but this way, when you are using simvehicle.py, you have much more capability in your hands. You can connect to You can change the airframe, you can change your aircraft settings, you can change the firmware, and you have many options in your hands. Okay, and for the last things, if you want to change the for example, the p-values, for example, I told you the p-value for this aircraft is not okay. You have to come to parameters. I don't know where's the PID tuning in QGround, but okay, you have to come to parameters and search for the associated value. For example, you see here when I search PID, this one is HRS, yeah, P. Different parameters are available for roll, pitch, and throttle control, and each one of them has a PID value, filters, and so on. You can change them. If you don't find the value here, go to Mission Planner. Because we are using Ardupilot, Mission Planner has much more capability for changing these advanced parameters. I think everything is, I've talked about everything you need here. And you can come here and download the log data or use the console or Maverick inspector that you can in real time see the values for the sensors, for the simulated sensors, and have the plot on real time. Very great capability here. And that's it. There are other methods here, for example, for flying a helicopter. You can also have a helicopter in X-plane that is controlled by PXOC. It's much more challenging because you need to add the support for cyclic flap, because helicopter control is much more harder. But everything is described here. You can use the documentation and follow the path. Let me close the explain so we have a good speed here. These are the steps you need to follow for helicopter control in software in the loop with explain. And you can also, if you want a multi-rotor, you can come here and use the tutorial for SDK. Because for simulating a quadcopter, you need to build the explain plugin to convert the roll pitch commands to the change of RPM for each motor, or you can use third-party plugins available in the web. They are available, I have seen some. And this is the simple way I was talking to you about. You come here, click on plane, select X-plane, and everything's happened in just seconds. You don't need to build software in the loop by yourself. It's just the simplest way you can have. I will put the link for this here, and if you have any questions or any feedbacks or any comments, please let me know in the comment, and like, subscribe, and share if you like this comment. I will try to put new videos about these things in the near future. And this is Tehran map. Thank you very much. Thank you for watching. If you have any question, again, ask me and I'll try to answer for that. And if you have any recommendation for the next tutorial, let me know. And I hope at the time that I'm recording this video, the coronavirus is spreading very hard in this world. I don't know when you are watching this video, is it over or not. I hope everyone be healthy and this coronavirus finishes soon. Happy flying, happy simulation, goodbye.